Hi everybody, welcome to section 14.2 in Calculus 3. Finally, we go to Calculus. So earlier we have a vector value function given like this. F and G and H are differentiable, so we're going to take derivative, obviously. And it is differentiable on A and B. Doesn't mean that it is upon A and B. When we write A and B like this, we mean T is between A and B. Right. And we define the derivative of the vector. It's just the derivative of the component functions. So derivative of the vector value function is the derivative of each of the component function. Right. And if the derivative not equal to a zero vector, this would be a zero vector. So just say zero vector and if the derivative is not equal to zero vector, then the tangent, it is called the tangent vector or the velocity vector at the point corresponding to this. So we haven't reviewed much in calculus either, but in this section we just reviewed two fundamental concepts of calculus: derivative and integral. So compute the derivative of the following functions. We'll take derivative of this. So I will rewrite this as power of t. So t cubed, 2 square root of t, I can write 2 t to the 1/2 power, and 3 over t, move t up, become t to -1. So we haven't done any derivative yet. We just rewrite that all the t as power, everything as power of t. Then we use the power rule. So if the function is that, then the derivative, we'll check derivative of t cubed will be 3t squared, of 2t to the 1/2, I take down the 1/2, and original power of 1/2 minus 1, 1/2 minus 1 is minus 1/2. And then derivative of this, 3 -1, t to original power minus 1 becomes minus 2. Rewrite this, we have 3t squared, that cancel out, just have t to -1/2, and -3 t to -2, and we rewrite this, we have 3t squared, t to -1/2 we move to the bottom, become t to the 1/2, and take the we don't do any more derivative, we just rewrite this, so move the t to -2 down, become t squared. Right. If we want to, we can write this as the square root. So we have 3t squared, 1 over square root of t, and -3 over t squared. Right. So we can leave the answer in this form, or this form. Everything's fine. Right. So that is the power rule, derivative using power rule. Right. Next, of course, when we can write a vector value function as the vector component in the triangular bracket, or we can use ijk component. Either way is fine. So when we take derivative of that vector value function, we will just take derivative of each one of them. So I just write e to -t. We'll take derivative of that. I component then take derivative of the 2 cosine t j component and derivative. That function go with the k component. Right. So just like this, but just different notation. Right, derivative of this. This is the power rule. I mean, the chain rule. Put the parentheses here. Around that, e to negative t is going to be the same thing. E to the parentheses, but we have to take derivative of the parentheses. So that is the chain rule. Doesn't matter what inside the parentheses though. We have negative t in this case, but in general, doesn't matter what it is. Be the parentheses and the parentheses derivative. Right, derivative of 2 cosine t, no chain rule here. We just say negative 2 sine t. That's easy. So that is the derivative with the j component. Derivative of ln of t is 1 over t. Right, that's simple enough, right? Just one more thing though. If we write like this, ln of t, ln of a negative number is undefined. So for this to work, we do need to have t greater than 0. So in that case, all of them are defined. ln of 0 is undefined either. So I have to have greater than 0 for all of them to be defined. And then of course, here we can say that could be derivative of negative t is 1. Remember, there's still the derivative here. So that's just negative 1 times this. So we have negative e to the negative t. Alright. You don't have to write like this. Just as long as you can take derivative. That's all we need for this part. Right. So straightforward, right? Now, what we define next is the unit tangent vector. So it is a unit vector, so the length is equal to 1. So basically, we just take the derivative, divide by the magnitude of it. By the way, when we divide like this, the denominator cannot equal to 0. So in this case, so that's not going to be a 0 vector either way. Right, so that is the unit tangent vector. Again, straightforward. We take derivative and then divide by the magnitudes of the derivative. So if this is the function, first we'll take derivative. It's going to be 2t, 4, and 4 times 1 over t. So 2t, 4, and 4 over t. Right, and then the magnitude of that vector, it is still just a vector, so we have the square root of the sum of the square of the components, so Pythagorean theorem. So we have 4t squared plus 16 over t squared. We could simplify this, but let's not do that. Run out of space here anyway. So we have derivative over the magnitude is the unit tangent vector. So the unit tangent vector, by the way, this is capital T and this is the vector, so that is the boldface T. Derivative, magnitude of the derivative. over square root 4t square plus 16 over t square. Right, so that's all we do. Right. The next example will actually simplify it. Right, so derivative over the magnitude of the derivative is the unit tangent vector. Right. So here the same thing. First we'll take derivative. Derivative of tan constant. Derivative constant is 0. Derivative of 3 cosine t is negative 3 sine t. And derivative of 3 sine t is 3 cosine t. And now let's find the magnitude. Square root and then the sum of the square of the components. Zero square is 0. Negative 3 square is 9 sine square, so 9 sine square plus 9 cosine square, and sine square plus cosine square is 1, but first let's factor out the 9. So we just have square root of 9, which is 3. Sine square plus cosine square is 1. We see this quite a few times already. We use a lot of that in the parameterized ellipse or circle. Anyway, so derivative over magnitude is the unit tangent vector so derivative over the magnitude, divide all of that, you have 0 divided by 3 is 0. Negative 3 and 3 cancel out, negative sine t, and 3 and 3 cancel out, cosine t. So in this case actually it turned out it simplified nicely. Right, next we have the derivative rules. So this is not much different than the rules we have. Right. Let u and v be differentiable vector value functions. So those are vectors u and v. F is a scalar function, so this is a regular phase. And c is a constant vector, that's why it is a bold phase. This rule. So first we have derivative of a constant is equal to 0. And the next three here we have, actually the next one is derivative of the sum is the sum of the derivatives. Whether it is could be subtract, still apply. The next three rules, those are the product rule. But the product rule, but with the function and the vector, there are three different products. We have the function times the product. There's nothing in the middle. We have the dot product, a dot in the middle between two vectors, and the cross product, of course, that simple. So the product is derivative of the first times the second, where there is and the derivative of the first times the second plus the first time derivative of the second. So of course I still apply for a scalar function So if it is the scalar product, it will be scalar product. Dot product will be dot product. Cross product will be cross product. And next one is the chain rule. So derivative of the vector value function composed of, I think I missed one parenthesis here, composed of another function is derivative of that, and then we take derivative of the function of t. So we do that. Right. So nothing out of ordinary. Right, first, now let's go to an example. Compute the following derivatives. We have those are the derivative. Now let's just calculate this. We're going to do that both ways. Okay, let's say just fold the page in half so we. So first we're just going to say we do v of t squared first. By the way, I should write just the vector v. Vector v of t squared, meaning that this is the vector v. Instead of have t, we're going to put t squared in for t, so we have v of t squared and then sine of t squared and then cosine of t squared k. Alright, now we take derivative. We can use this notation or just use the prime sign. Perfectly fine, but I just say we have derivative of that. So I said the notation should not be problem here. So we just take derivative of this. Usually if the question like that, you can just use the components or use this. And then we take derivative. We can write d over dt, or we just use that Lagrange notation. Right, and we take derivative. Derivative of this. This is the chain rule. I put parentheses around t squared here. So sine of t squared, doesn't matter, sine of whatever, we have sine of that and time derivative of it. So that is the chain rule. Then same thing, cosine of something and derivative of that times k. So here we have t squared, t squared, t squared, t squared. So we have just some t squared, derivative of t squared is 2t, so we have 2t sine of t squared, right, and of course there's a problem here, right? Derivative of sine is cosine. Yeah, so we take derivative here to there, so this will be cosine. And derivative of cosine is negative sine. Sorry about that. And then the t squared derivative is 2t. So minus 2t sine of t squared k. Right, so we can do that. Right. Another way to do that is using the formula. We're going to do this. So derivative of v that's redundant. Either use the prime or use that. So derivative of that is going to be derivative of that, and then derivative of whatever inside. So in general, that's how the chain rule works. Doesn't matter what inside the parentheses, it's going to be like that. Now what we have is t squared right. Now we're going to take derivative. Let's ignore that for a moment. Now we will take derivative of v, but we're going to put t squared into it, right? So derivative of sine t is cosine and then we're going to put t squared into it times I. Derivative of cosine is negative sine. Doesn't matter what inside, but inside is t squared. And then we'll take derivative of t squared is 2t. Because if we multiply it out, we have 2t cosine of t squared I minus 2t. Oh, I forgot the k here. And then minus 2t multiply to that sine of t squared k. Right. So really way it works. Sometimes I just prefer to just do it like this. It is a lot easier. Right. Next, we have a dot product. Let's keep this in two different ways. We still have the function u and v like that. Right, first, derivative of the dot product. It's just the product rule with the dot product. So we're going to have u prime dot v either up t or not, it doesn't matter, plus. Let's just actually let's just be consistent with the last example. First we just multiply it out. So u of t dot v of t. Right. Well, it's not going to be friendly. Right. So the dot product t squared and negative t cubed. Do the dot product with sine of t for I. So the first component is sine t. There's no j. And there's a k, so that will be cosine. Right. So the dot product is equal to t sine t. 0 times that is 0, and negative t cubed cosine of t. Now we take the derivative of the dot product. To derivative of the dot product or derivative of this. I should have more space here. Just derivative of this pretty much. Right. Yeah. T sine t by itself is a dot product. So dot product uv u prime v plus uv prime. So derivative of t is 1, and then sine t plus t, derivative of sine t is cosine t. I have to write a little smaller because we don't have much space here. 0, derivative 0 is still 0. Derivative of negative 3 t cubed is negative 3t squared, and then cosine t, and then we have negative t cubed. Derivative of cosine t is negative sine t. So put those together, negative and negative. The only thing we can simplify here is sine t plus t cosine t 0, and then we have negative 3 t squared cosine t, negative that plus t cubed sine t. Right. Now let's use the dot product in, the product rule in the dot product form. So d over dt of the dot product is derivative of u dot v plus u times derivative of v. Right. So again, I will write using the component like this. Have space. Once again, we have u and v like that. So derivative of u, derivative of that, 1, 2t, negative 3t cubed, negative 3t squared, right? Sorry. And then dot product with v in component would be sine t, 0 for second component, and cosine of t for the third, and then plus u of t squared, negative t cubed, and then derivative of this, derivative of sine t is cosine of t, and then derivative of second component 0, derivative of cosine t is negative sine t for k. Now just multiply it out and then combine. 1 times that is still sine t, 2t times that 0, still need to write 0, and negative 3t squared cosine t, and then plus t times cosine t, 0 times that, and negative that to plus t cubed sine t, and then we combine the vectors, sine t plus t cosine t in, don't forget the 0 component. Negative is positive. T cubed sine t. Right. That's the first component. In the middle, there's nothing. And then negative 3 t square cosine t plus t cubed sine t. So sine t cosine t 0, negative 3t square cosine t, and that, yeah, so should be the same. Yeah, sometimes we do the product anyway, but the product rule anyway, but yeah, sometimes write like this is easy to keep track of compared to this, where we have to do the product rule for each one of them. Yeah, still pretty comparable here. So what's next is we have t squared times that. So t squared times u of t. So this is a scalar function times that function. So we did a lot of things except for the cross product. Right. So first, again, we just multiply t squared u of t first. And u of t is that. Again, I will write in the components t for the first one, t squared for the second one, and negative t cubed for the third component. Multiply straight across. T cubed, t to the fourth, minus t to the fifth. Right. Now we take the derivative of this. T cubed, t to the fourth, negative t to the fifth, derivative derivative of this will be just 3t squared 4t cubed and minus 5 t to the fifth, to the fourth, sorry. Right. So, yeah, so we can just do it in the sign of parentheses first and then take the derivative. Or we can just use the product rule. So the product rule here with the t squared, so we have derivative. I'm just going to say it, derivative of t squared, just regular product with u of t plus t squared times derivative of u. Yeah. So it is the product rule, but in the scalar product form. Derivative of t squared is 2t, and then u of t is this. T squared negative t cubed, then plus t squared, derivative of u, derivative of that, 1, 2t, negative 3 t squared, multiply out 2t squared 2t cubed minus 2t to the fourth plus t squared 2t cubed minus 3t to the fourth, and combine them we will have 2t squared plus t squared 3t squared, 2 and 2 make it 4, and negative 2 and negative 3, that's negative 5. Of course we should have the same thing, whether we do inside the parentheses first or we apply the product rule, it's still the same. Right, so I just derivative. Now we'll take the derivative of this. Actually, first, second, and third derivative. Right, so the first derivative of t squared 2t. Derivative of ln of t is 1 over t, and then times 8, and then derivative of e to something, just to change rule, e to that, and then derivative of, yeah, I'm just going to write like that. If you don't want to, it's perfectly fine. Just make sure we do it correctly. Right. So it will be 2t, 8 over t, and then that's negative 2 times t. Derivative is negative 2 times 3 is negative 6. E to the negative 2t. Right, so we do that. Let's just write a over t as a to the t to negative 1. So 2t, a to t to negative 1, and negative 6, e to negative 2t. Right, so that's the first derivative. Now the second, I better write from here. So second derivative. Derivative of 2t is 2. Derivative is 8 times negative 1 t to negative 2, just regular power rule, and then negative 6. Derivative of e to negative 2t is going to be just that. So in this case, I just said of e to negative 2t is e to the same thing, and then derivative of negative 2t is negative 2. Right. So 2, negative 8, t to negative 2, and negative that's a plus 12, e to negative 2t. Then take derivative one more time. Derivative of 2 is 0. Derivative of this, take down the negative 2. And then original power minus 1. And then we have 12, e to negative 2t, same thing. And derivative of negative 2t, negative 2. Right, so we have 0, 16, t to negative 3, and negative 24, e to negative 2t. And then the third derivative. 0 is still 0. Derivative of this, take down negative 3, negative 48, t to the negative 4. And then we have negative 24, then times negative 2 again, so that will give us 48, e to negative 2t. Right, so negative 24 times that, and then we have negative 2 times negative 24 is 48. Right, so just derivative like we normally do. Right, now so I negative 2, negative. Integral. When we differentiate, there's no problem. Now we integrate. So integrate the vector-value function. We will integrate each component function. So do the antiderivative of each one of them, and at the end we have the constant c. This is the vector, so we write that as a boldface C. Just one thing before we go to integrate though. When we integrate, remember when we take derivative of something like e to negative 2t, we're going to write the same thing and then multiply by the coefficient negative 2. So when we take derivative, we multiply to those. If we integrate, we will divide. You will see. So let's look at this problem. So first thing we do is when we integrate the vector value function. By the way, the notation is the integral sign and then the vector value function and then dt. So whatever between the integral and dt, we're going to integrate that. So integrate that, we can just put the integral to each one of them. So I'm going to say it. I will integrate t over square root of t squared plus 2 dt. That for the I component. And now for the j, still integral. So we integrate each one of them. J. And then integrate sine of 3t dt. Okay. Alright. Now we integrate each one of them. Should be no problem. But the first one, to integrate this, we use the chain rule. I mean, substitution, U substitution. I'm not sure how you use the U substitution, but this is how I use it. We let U equal to something, and then we solve for dt. So for derivative of that. So you see. So here we let U just regular U equal to 2 squared plus 2. And then we'll take derivative of that. Du over dt is 2t. Multiply the dt. And then divide by the 2t. So we have u and we have dt. Let's substitute into that. Like I said, we worry about the orders later. If I write equal here, kind of awkward. So let's say this is equal to the integral I. Right. So now we have the integral t on top. Square root of t squared plus 2, so that will be u, and dt is du over 2t. With I component, t and t cancel out. There's a 2. I will take it outside the integral, but stay at the bottom. T and t cancel out, and 2. Square root of u at the bottom. I just write u to the 1/2. And move to the top. So I just do 1 by 1 because u to the negative 1/2 du. Alright. And then integrate will be 1/2 u to 1/2. Negative 1/2 plus 1 is 1, positive 1/2, and then divide by 1/2. Now, so it's like that. Now the 1/2, the 2 at the bottom, and then the 1/2, actually, both of those two are at the bottom. 2 and 1/2 cancel out. So we just have u to the 1/2. Alright, so that's the first component. The derivative of this should be easy. If you don't want to, you can just do the chain rule again here. But later on, it will save you a lot of time. We just said integral of e to something is going to be e to the same thing divided by the -5, the coefficient of that. All right, let's just use substitution one more time. Right. Here we have u already, so let's use something else. So let v be the -5t. I said you don't need to do this. And then dv over dt equal to -5. Multiply the dt over dv is equal to -5 dt, and then divide by -5. dv over -5 is equal to dt. You don't need to do this. But if you do, we have e, -5t is v, dt is dv over -5. For j, I said this is a good review for calculus. -5 here, take it on the outside. Stay at the bottom. Just e to the v, dv, j component. And that's just -1/5. E to the v is e to the v, that integral. J component. Right, so we have now we can substitute back in for v is -5t. Of course, we can do the substitution, the same thing for sine of 3t. But notice that if this is just the linear function of -5t, we just do integrate of that, integrate of exponential function, and then either divide by -5 or multiply by 1 over -5, either way. So integral of sine, if it is 3t, 5t, 100t, doesn't matter. Integral of sine is negative cosine, right? So we're going to have negative cosine. We could use the substitution like we just did, but I'm just skip that. So it's going to be cosine. The integral of sine is negative cosine. In this case we have 3t, right? And then for integral of a linear function, like a constant time t, we're going to divide by that constant. That is the k component. And don't forget all of this at the end, that is the constant vector. So we just have -1 over 3 cosine 3t k plus at k. And then plus -1 over 3 cosine 3t k. I can put this in component. U is t squared plus 2, so I'm just going to write t squared plus 2 to the 1/2, negative 1/5 e to negative 5t, and then negative 1/3 cosine 3t plus the constant vector. Yeah, whether we can just go directly to this or we use substitution rule. It's easy. But in general, when we integrate, we just integrate the function. E is going to be e the same thing, and then divide by the coefficient of t. 1/-5. Coefficient of t is 3, so divide by 3. So that's what we have. Right. Next we have a couple, actually two, what we call the initial value problem. What we do is, if we have the derivative, to undo the derivative, we integrate. So r of t is that. So to get back to r of t, we will integrate r of t derivative so integrate this where we integrate the constant e square is a constant, e square is a constant square. Sorry, constant square is still a constant, so integral of a constant, I'll just multiply by t. Integral of sine t is negative cosine t. Integral of t is t squared over 2. As always, that vector constant. Right. So undo derivative gives back to the antiderivative plus a constant c. Right. Now we use the initial value problem. It's this condition. R of 0 meaning t is equal to 0. So we say at t equal to 0, R of 0 equal to j. What is j? 0, 1, 0, right? K is 0, 0, 1. I is 1, 0, 0. So j is second component, so we have 1 there. Right. Now let's just rewrite this and put 0 in for t. So we can say, of course I can write this as a vector as well, but I'm just going to, I can write this, the c here as a vector component of c1, c2, and c3, but I'm not going to do that. Just going to keep the constant c like that. Right, I'm just going to put 0 in here and equate all of that into this. So on the left hand side where I put 0 in, I will have e square t will be times 0, negative cosine of 0, and then 0 square over 2 plus c, that equal to 0, 1, and 0. So 0 that would times that would be 0, cosine of 0 is 1, 0 divided by 2 is still 0, plus c. Move this to the other side, so c equal to 0, 1, 0, subtract 0, negative 1, 0. So that gives us 0, 1 minus negative 1 is 2, 0, that should be 0. So we solve for that vector constant c, and then we can just substitute that back into this, and that is our answer. I'll just going to write like that. Actually, it can be better. Right, so we send, we write r of t is equal to e squared t minus cosine of t squared over 2 plus c is this. Now we add the components because add 0 is itself negative cosine t plus 2 and that plus 0 right. You can check easily when t equal to 0, so that's 0, that's 0, negative 1 plus 2 is 1, so that's good. And then we can check derivative. E squared, derivative of cosine is negative sine, which is now the negative. Get back to sine, and derivative of that is t. So that's work. Right. So if we are given derivative and antiderivative, so we integrate with us an antiderivative plus c. And then we solve for c. Right. Find a function that satisfies this condition. So that is the derivative. To get back to the function, just integrate it. Integrate the derivative. That may be with the constant c though. Anyway, so integrate this square root of t cosine pi t and 4 over t dt. We'll integrate. Before we integrate, I just want to rewrite square root of t as t to 1/2. I prefer to integrate that way. So we still have integral t to 1/2 cosine pi t 4, and then you can say times 1 over t if you want to dt, because integral 1 over t is ln of absolute values of t, so that's fine. Right, integrate this, give us t to the 3/2 over 3/2. Integral of cosine is sine, and then we multiply, actually divide by the coefficient of t. And then integral of this is 4 ln of absolute values of t plus the constant vector c. Divided by 3/2 is multiplied by 2/3. And I just write 1 over pi sine pi t and then 4 ln of t, ln absolute value of t plus c. And now we have the initial value problem here. And that is of course where t equal to 1. So at t equal to 1, r of 1 2, 3, and 4. So I'm going to put 1 in for t and equate that to 2, 3, and 4. Now put 1 in for t, 2/3, 1 to the 3/2, 1 over for pi sine, t is 1, so I just say sine of pi, and then 4 ln absolute values of 1 or just 1 plus the vector c, that's supposed to be equal to 2, 3, and 4. So what is ln of 1? That should be 0, right? Yeah. So it's clear to simplify this. So we have 2/3. Sine of pi is 0, so we have 0. And ln of 1 is still 0. Plus c equal to 2, 3, and 4. If we want to solve for it, 2, 3, and 4 minus 2/3, 0 and 0. 2 minus 2 over 3. 2 is 6 over 3, so 4 over 3, so 4/3. 3 and then 4. Right. We found the vector constant. Just put back into this. So we have of t equal to 2/3 t to the 3/2 1 over pi sine of pi t 4 ln of absolute value of t plus 4/3 3 and then 4. We can add the components with components, or we're just going to leave it like this. Perfectly fine. Just check it real quick. Derivative of this give us t to the 1/2, which is good. Derivative of this, derivative of sine, cosine, so cosine, and then times pi and pi cancel out. So yes, that's good. Derivative ln of t is 4 over t, so that's also good. And then the initial value problem, when we put 1 in here, you have 2/3 plus 4/3, 6 over 3 is 2, so that's good. Now if you put 1 in here, that is 0 plus 3 give us 3, and then if you put 1 in here, that's 0 plus 4 give us 4. So yeah, that's look good. Alright, so that is indefinite integral. Now we can also have definite integral where we have the limit. In that case we still just integrate which one with the limit. So that's again should not be any problem. So when we integrate like this, we're going to integrate. By the way, when we integrate, we can integrate into the vector form, or we can have the ijk component, still the same. But if it doesn't have anything here, it's going to be 1 in front of it. So this we can say integral from 0 to pi of 1 dt. That is for the I component. And then plus integrate of this each one of them have the integral and then the dt. This for j. Whether we say minus or put the minus in the integral or not, it doesn't matter. I'm just going to leave the minus outside. That with the k component. Yeah, so the negative, why like that? Right. Integral of 1 is t. So 1 is t. That goes from 0 to pi. Integral of this, integral of cosine is sine, right? So sine of the same thing, and then we divide by the coefficient of t, in this case 1/2. Limits. By the way, inside parentheses, t over 2. Limit from 0 to pi. Subtract integral of this 4 t squared over 2, integral from 0 to pi. This is definite integral. By the way, I forgot the I, j, and k, right? Don't forget that. And this is definite integral with the limit. We will not have the constant c. Yeah. So not much different than the previous one, except this time we have the limits. Definite integral. So we just evaluate. Put pi and put 0 in. So we have just pi minus 0. I. And then 3. By the way, either you write I, j, k or you use the bracket. Don't put the comma here. That's totally wrong. Right, I'm going to put pi here. Don't forget that's a 1/2. 1 over 1/2. 1 over 1/2 multiplied reciprocal of 2 over 1. So that's just 2. And then subtract, we're going to put 0 in it. Let's say 0 over, okay. 0 over 2 is still 0. And then multiply by 1, divide by 1/2, or multiply by 2 in the j component. 4 and 2 cancel out, so that's 2t squared. 2t squared. First t is equal to pi, and then t squared where t equal to 0. Okay. So we have pi I. Sine of 0 is 0. Sine of pi over 2 is 1. So that 3 times 2 is 6. J. And that is negative 2 pi square k component. Or we can just write pi 6 and negative 2 pi square. Right. So there's not much in this section. What we do is actually we differentiate a vector value function and integrate vector value function. For that, we just differentiate each component, or we can, or when we integrate each component. Where there is definite integral with the limit, or where there indefinite integral, we require the vector constant c. Or of course, or we can have some like the product rule in different forms. But other than that, this is more like the review of calculus 1 or calculus 1, basic, derivative, and integral. Yeah, so that's all we cover in this section. Thank you for watching.